Hi everyone. As you can see, it's Galvis. I'm back with more interesting problems to solve. Alright, today I have a very interesting example to illustrate the substitution method. Alright, here we are asked to determine the order pair x and y that will satisfy both equations. Alright, so what are those two values? That will give you negative 17 in equation number 1, and that at the same time that will give you 8 in equation number 2. In other words, when you multiply negative 3 times a certain value of x and you add up to this term 2 times another value of y, it will give you 8, but at the same time these two values will satisfy equation number 1. Right. Substitution method is a very practical and simple method for you to use and determine that order pair. But of course you're free to choose. You can go for elimination or determinants, or for instance you can apply graphing or matrix. Either one of the four methods is fine, but in this case I'm going to illustrate one which is simple and is substitution, right? When you apply substitution method, the first thing you have to do is that you have to solve for x in both equations. First, let's solve for x in equation number 1. Clearly here, when you have a negative term being subtracted from this one, what you do when you bring it to the right hand side is that you switch the sign. So this is negative, so it will become positive right here. So this will be 2x minus 17 plus 3y. And notice that this is positive right here because this term was on the left hand side, it had a negative sign, alright, a minus sign here in front. So this means that when you bring it to the right hand side, it becomes positive right here. This 2 is multiplying the x. So what you do with this 2 is that you bring it downstairs, dividing out the whole expression on top. In this case, 2 is going to divide out the whole expression, negative 17 plus 3y. And this is going to be my equation number 3. Alright, I repeat the same process in equation number 2. So let me solve for x in equation number 2. So in order for you to solve for x in this equation, negative 3x is equal to 8, and remember, once again, this is positive 2y. Once you bring it to the right hand side, it becomes negative, so it's going to be minus 2y. Alright, and this negative 3, which is multiplying the variable, it will be down here dividing out the expression a minus 2y, which is my equation number 4. Clearly these two equations must be equal to each other. The reason being is because both expressions are being equal to x. And no negotiable here. These two things must be equal to each other. So what I do here is that I let x, the value of x from equation number 3, be equal to the value of x from equation number 4. And this is illustrated in the next step. Right here, negative 17 plus 3y over 2, it's equal to 8 minus 2y over negative 3. So as you can see from this equation, I have removed x, so I end up with y, so I can solve for y because I only have one unknown in one equation, which is linear, by the way. And so now this negative 3 is going to multiply the whole expression on top here, and this 2 is going to multiply, since it's dividing on the left, is going to multiply the expression on the right. So negative 3 times negative 17 is 51. Negative 3 times 3y is negative 9y. And 2 times 8 is 16. And 2 times negative 2 is negative 4. Then we group together y's on one side and numbers on the other. And what we have right here is 51 minus 16. This is positive. When you bring it to the left, it becomes negative. And the same happens to the terms having the variable y. This is negative 9y. Once you bring it to the right, it becomes positive right here. And clearly 9 minus 4 is 5, and 51 minus 16 is 35. And so what you do here, the final step, is that this 5 that is multiplying the y, you bring it downstairs, dividing out the 35 over 5, it's equal to 7. Basically what you're doing here is that you are dividing out both sides by 5. Alright, you're dividing this 5 is going to divide out this both terms, right? So this is 7. So y clearly is 7. So once I have the value of y, I can go for x. I can either use equation number 3 or 4 in order to determine the value of x. Either one of the two is fine. Either one of the two will work perfectly because remember, both expressions are the same. They're both equal to x. And so if I use, for instance, equation number 3 will be negative 17 plus 3 times y. But y is this number right here. So this would be negative 17 plus 3 times y. So that means negative 17 plus 21 over 2. And clearly this, I'm subtracting 17 from 21. That gives me 4 over 2 is 2. So clearly the value of x is 2. So my order pair, which is the solution to the problem, to the given system, is 2, 7. So 2, 7 is the solution to my original system of equations right here. And we can check that. We can check that in D. These two values, these order pair x and y, will satisfy both equations. And here is the checking our work part. All right. In order for you to check that your answers are correct, what you do is you substitute the value of x and y that you just found, and if they give you negative 17 in equation number 1 and 8 in equation number 2, then those values for x and y are correct. If not, then somehow you made some mistakes when going through the process. But remember, here you have to be systematic. All right, apply each of the steps correctly. Go step by step, carefully, taking care of the signs and solving for x and y in a very proper way. Okay, if you follow the steps as I just explained right here, you will have no problems. All right, with your final solution. So let's check our answers. Let's check our work. 2 times x, but x we found that is right here is x is right here, excuse me, x is 2. So clearly 2 times 2 minus 3 times y, but y we found that is 7. So here we check our work. 2 times 2, which is x, minus 3 times 7, which is y, is 4 minus 21, because 2 times 2 is 4 and 3 times 7 is 21. And when we subtract 21 from 4, that gives me negative 17. So they checked out the first equation. Now let's try to check that indeed these values will satisfy equation number 2, right, in the same way as they satisfy equation number 1. Negative 3 times x, which is 2, plus 2 times y, which is 7. As you can see, this part of the problem is this one right here. I'm just substituting the value of x and y, which I already found, and I'm multiplying each value. In this case, I'm multiplying by negative 3 and then by 2 respectively, all right, the values of x and y, and that has to give me a. Let's see if that's the case. Negative 3 times 2 is negative 6, and 2 times 7 is 14. Clearly, negative 6 plus 14 is 8. So both values of x and y checked out both equations. So in this case, I can say that this order pair 2, 7, the order pair x and y 2, 7, is our final solution to the given problem. All right, and we can check that indeed those two values will satisfy. We already checked that indeed those two values satisfied both equations. All right, so this is our final answer. We checked our work. We're done with this problem. I hope you find this video very interesting and useful. And please, if you have questions, post the questions, like my video, and I will be more than pleased to answer to your question, to give an answer to each of the questions you post. All right. So thank you very much for watching. This is Galvis. All right, never forget me, and see you next time. All right, bye.